Hello. So, suppose you have 4 red berries, okay? And you want to eat them because they're sweet. So, don't hesitate, eat them. But now, I think there are more people than you are because you have a family. And in this family there's Papa, who's the big one, and Mama, a little bit smaller, and then your little sister, and maybe yourself, okay? So, and you want to equally divide the 4 berries to the 4 people. So what you need is to calculate. It's very easy in this case. You have 4 berries, and then you divide it by 4 people, and then you get 1. So maybe better write it like this. You can't discern between the numbers, but you need 1 berry, or you get 1 berry per person, because the first berry is for Papa, the second for Mama, the third one for your little sister, and the fourth for yourself. So that's clear and that's easy. But things can become very complicated. For example, you have a big pizza, ordered this for lunch. Oh, it's not a nice pizza, maybe more round, like this. And you're all hungry. And there's Papa and Mama and your little sister and yourself. And everybody wants to get the same. So what do? So now you have to divide 1 pizza by 4 people. And the question is, how much pizza does everybody get if you divide it equally? That's very, very complicated. So what would you do? You would have this round pizza, and what steps would you like to do? So the best thing would be to cut it. You have to cut it equally into 4 pieces, so you know how to do this. You cut it this way, and then you have 4 roughly equally sized pieces. So the result is 1/4. And you see this equal sign, which means it's the same like a balance. You know what a balance is? Hopefully. Something like this, and on top it's rotatable here at this point, and here's something, and here's something, and if this is straight horizontal line, then you have here something and here's something, and maybe on the right hand side you have more pieces, and here you have just 1 piece, but it's the same, okay? Here you have 1 piece, and here you have, for example, 4 pieces, but these have to be 1/4 of the size of this one, else there won't be a balance. Okay, and this is also means this is the balance. So this is the same. This equals this side equals this side. So they are just 2 different ways of writing 1 divided by 4. Nothing else. This is a fraction called a fraction. Got its own name, and this is a number. It's a quarter. It's 1/4. Nothing more. So 1/4. This is 1/4 here. And also this is 1/4. And also this is 1/4. And finally also this is 1/4. Okay, so and here you can see, if you add all these 4ths together, so I'm just doing it like this, it's a little bit faster. 1/4 plus 1/4 plus 1/4 plus 1/4. It's the same. Then we have 4 times 1/4, which is finally 1 pizza. You remember, if you add all these things together, then you have the big pizza again. So what you see here in this case, it's easy. And what you see here, if you add fractions, I have to have the common denominator. So all things have to have names, else you can't call them. So therefore you have to learn these names. So what is the common denominator in this case? So in this case, if you look something like this, 1/4, then the 4 is the denominator, and the 1 is the numerator. Okay? So, and if you want to add all these, have the common denominator. I will do it on the next side, okay? So you have 1/4, you have it 4 times. It doesn't matter how often you have it. In this case, we just add it together to one pizza again. All have the common denominator, and what you then do is just use the one common denominator and then add all numerators together on top of the line. Okay? And there's nothing complicated. It's 1 plus 1 is 2, plus 1 is 3, plus 1 is 4. So you have 4 in the numerator and 4 in the denominator. So this was quite easy. So what we mean by this is that we have one part of our pizza and another part of our pizza and another part of our pizza and again another part of our pizza, and now we put them all together, and then we have these 4 pieces merged together, again giving a whole pizza. So let's make another calculation. So if we have 1/4 of a pizza and add another 1/4 of a pizza, what would we expect then doing this? So for example, if we put together this part of a pizza and this part of a pizza, so what we expect is that we get this part. So this is half of a pizza. You agree? This is 2/4, which should be the same as 1/2. So how can we explain this? This is the same. So again, doing the calculation, we have to have a common denominator, which is in this case given, which is 4, and then we have to add the 2 numerators. Once again, I'm sorry. So we have this, and finally you got this, what we expect, and we know this is half of a pizza, so this is 1/2. So why should this be the same? What can we do? So, and now we can do a reduction of a fraction. So what does this mean, reduction of a fraction? So first we have to look for something else. If you remember, if you have a number, let's say you have the number 3, and you multiply it with 1, what would you expect to have? So you have 1 times 3, so you would expect to have a 3. And if you have a 4 and multiply it with 1, so you have 1 times 4, which is also 4. So if you multiply a number with 1, then you get the number. So number times 1 gives the number. So therefore, if you multiply multiplication of a number with 1 gives the number. Let's talk it unchanged number. So if you multiply anything with 1, nothing will change. You will get what you have multiplied with. So, and now if you remember to the thing before, we had something like 2 divided by 4. Yeah? Remember, we have something like this here, 2 times 1/4, which is 2/4 of a pizza, merged together giving a half a pizza. And we would expect that this is the same than 1 divided by 2. How can this go? So first, if you have 2 divided by 4, you can also say you have something like 2 times 2, which is 4. And what you also have is 2 times 1. You agree? 1 times 2 is multiplication with 1. Does not change 2. You get 2. And if you look at this, 2 times 2 is the same as 4. So I didn't change the numerator, because 2 times 1 is the same as 2. And I didn't change the denominator. I just wrote it up in a different way. I said 4 is the same as 2 times 2. And what you now have is you have commons in the numerator and the denominator. And what you now can do is to cancel them out. So you have something like times 1 and times 2, and here is 2. And what you can do now is just cancel the common ones. And the numerator and denominator. And what you then get is, you cancel them out, you can write it this way. What you also can see is that you can multiply something with each other. So if you remember, we have 2/4, and say it's 2 times 1 divided by 2 times 2. And now you can do two things. You can, in the first instance, you can reduce the fraction by cancel the common factors and then remain with 1/2. Or you can divide it into 2 fractions and see what this means. You multiply 2/2 times 1/2, and then you get 2/4. And now you can ask, why is this the same than this? Well, you can immediately see this here is 2 times 1 divided by 2 times 2, and you can cancel out the 2, and then you have 1/2. And you know, if you multiply this in this way, then you get 1/2. Okay, and now here we can imagine that 2 divided by 2 is 1. You know that 2 divided by 2 is 1 because it's 2 divided by 2. So if you remember, you have 2 berries, and you have 2 people. How much will everybody get? Each of them will get 1 berry. So the result, if you divide 2 berries by 2 people, then each gets 1. Okay, so this is the same than this. So if you multiply 2 fractions together, then you multiply the numerators and you multiply the numbers in the denominator. So for the next thing, if you have, for example, 3/4 times 5/6 or something like this, so how do you do it? So you multiply the numerators and you multiply the denominators. 3 times 5 is 15, and 4 times 6 is the same as 2 times 2 times 6. It's a little bit more complicated, but you can multiply 2 times 6 and you know this is 12, and you can also have 2 times 12, which is 24. So maybe you see, or you don't see at this time, that both numbers can be divided by 3 because they have 3 in as a common factor. But you can see it here maybe. 3 times 5 is 4 times 6, and this is 3 times 5, and this is 4 times, and 6 is 2 times 3. So you see you have a common factor in the numerator and in the denominator, and you can cancel them, and then it's much more easy. So we have 5 divided by 2 times 4 is 8, so 5 divided by 8. It's the same then if you divide 15 by 3, then you get 5, and if you divide 24 by 3, then you get 8, and it's the same. Okay, so it's very useful to cancel out common factors, because the whole fractions becomes much smaller numbers and much easier. So in exercise number 1, you were given an equation which looks something like this, and the question is, what should be n to form a proportion in each item? So in this case you should remember what I taught you about the sign. It means equation. So you have a balance. You have something like this here, and it should be balanced, so it should be a straight line. And here you have something, and here you have something. In this case you have n divided by 8. In this case you have 10 divided by 16. And now the question is, what is n? So what you can do, for example, to get the answer for n would be, if here would be an 8, then you just have to see what's on top here, then it should be equal. I will show you what I mean. N divided by 8 should be 10 divided by 16, and you can make an 8 below. How? So one thing you should remember, you can cancel out common factors. So what you should make is to find a factorization here below, which equals the 16. So 16 is 8 times, and you would suggest it's 2. Am I right? Huh? So because 8 times 2 is 16, which is right. And on the top I didn't change anything. I just wrote it in another way, in a different way. And now you should see, well, if I would have a common factor like 2 here and here, so in the numerator and the denominator, I could cancel them out, and then I would have a number in the denominator which equals this, and then on top it should be also equal. So let's see, can we divide 10 by 2? So it's 2 times, and here we have 8 times 2. Yeah, it's 2 times what is 10? It's 5. If you have 2 times 5, it's 10. And now you can cancel out the common factors in the numerator and the denominator. And the result would be 5 divided by 8. Now I can write down n divided by 8 is 5 divided by 8. Everything should be equal. Now you can imagine if both denominators are equal, then also the numerators should be equal. And therefore you can find out n should also be 5, because you have a balance that should be the same. So what have we done? We didn't change 10 divided by 16. We just wrote it in the way 5. It's the same as 5 divided by 8, because they have 2 in common as a common factor, which can be cancelled out. Okay? So let's start with another exercise. It's called, let me have a look, it's number 6. I just use number 6. And it's n divided by 18 is 100 divided by 36. Okay, so what we can do? So it's the same as beforehand. You can see, can I write it down something like this? 18 times an unknown, because we want to have the same denominator. So you have to divide 36 by 18, or may suggest 1 would be not enough. 2 times 18 is 36. Great. Now we have to ask, can we factorize the numerator also by a factor of 2? So 2 times what is 100? It's 50. And we have 18 times 2. And what we can do is to cancel out the 2, and the remaining result would be 50 divided by 18. And we have n divided by 18 should be 50 divided by 18. So the denominator is the same. That's why we factored out the 2 here below. And then if the denominator is the same, the numerator should also be the same, else this equation would not hold. So therefore n is 50. Okay. So I use number 11, which states 90 divided by 38 is n divided by 76. Ooh, what's that? So it's nothing nothing complicated. You can just write it down like this, if you remember, and also the other side, and something like this. And now you can see we have to have this, let's say, the denominators in common. And now we should ask, how often do I need to multiply 38 to get 76? Because in this case, this factor here below the n, so the denominator is bigger than in this case. So we can also say, well, it's n divided by 38 times 2, because 38 times 2 is 76. Okay. So what we can do is multiply this whole thing with 1. This doesn't matter, but what we want to do is we just want to multiply it by 2 divided by 2. Why do we want this? Because we want to have 38 times 2, because this is the same than n divided by 38 times 2, because the denominator is the same. So therefore, to hold this, for this equation to hold, is that n should be 19 times 2, which is, I think, 38. Okay? Now we take number 7, which is 23 divided by 55 is 46 divided by n. Now the n is in the denominator, so what can we do? So in this case, we need to have to look at the numerator. They should be the same, and I can say 46 is 23 times 2 divided by n. So to have here 23 times 2, we have to multiply it with 2. And not to change anything, we also should multiply the denominator. If we won't do that, we would change the value of this whole fraction, and we are not allowed to change the value. because if you multiply the numerator and the denominator with the same number, we would be able to cancel them out. Yeah. And we get back the original fraction. In this case, this one here is the same. So it's allowed to multiply the numerator and the denominator each with the same number, because nothing will change. It's the same. We could cancel them out. We don't want to cancel them out because now we have this equation from here where we can see the numerator is the same. Therefore the denominator should also be the same. So n is 55 times 2, which is 110. How can I see this fast that 55 times 2 is 110? It's quite easy. 55 is the same than 11 times 5. And 55 times 2 is then the same as 11 times 5 times 2. And this is 11 times, and 2 times 5 is 10. And if you multiply a number by 10, you just have to take the number and add an O right to it. And then you have 110. I have another problem. I have 21 divided by 70 is so, and now I want to have a fraction or ratio which will make the equation a proportion. So it should be the same on the left and on the right hand side. What can you do? First, I would write it in that way. It's much easier to see. And what you can see is 7t is the same as 7 times 10. And 21 is the same as 7 times 3. So you have a common factor in the numerator and the denominator. You can cancel them out. And then you have 3 and then you have 3 divided by 10, which is the same than 3 divided by 10. So this would be the result. It's quite easy. It's the same. You have equal sign, and so it's the same. So if you divide 21 by 70 people, it's the same result. Then if you divide 3 by 10 people, you get 3/10. So that's the result. Number 3, 5 divided by 3. So we can do something like this. Now you will see you can't factorize them because they're prime numbers. What can you do? Well, you can multiply each with, for example, the easiest one to change the numbers would be to multiply each by 2. It's allowed, because if you multiply it by a common number, you can cancel them out, and the result would be the same as before. This is very important, else you would have changed the fraction, and that's not allowed. So you're allowed to do multiply on top and on the bottom with the same number. 2 times 5 is 10, and 3 times 2 is 6. So you get 10 divided by 6. So that's the same than 5 divided by 3. That's the result. Okay? Let's go ahead with exercise number 11, where you have 49 divided by 70. So what you can see is, I think we had this already. No? No, we had something like this. But I will also try to see whether you can factorize out 7. And you know, 7 times 7 is what? 49, you're right. And 7 times 10 is 70. So you see, you have a common factor here and here. You can cancel them out. And then you have 7 divided by 10. That's all. Well done.